Welcome back. In this video, we're going to be continuing with section 4.5, looking at some properties of logarithms. In these next couple of examples, we'll be rewriting some log expressions as single logarithms. So let's do that. So here, this one is all logarithm base 2's. By the way, for each of these, the base has to be the same, right? So if this first one was like log base 5 or something, then I couldn't combine the logarithms, okay? The bases have to be the same. You'll never in this class run into this situation like that where there's this type of question will have two different bases. Okay, so let's try this. So here we have a sum of two logarithms. We'll rewrite that as the single logarithm of a product. So that'll be the base 2 logarithm of a plus b, a minus b. And then in the back, I can tell like this 2 exponent, I'm going to want to bring that inside. So we'll call that base 2 logarithm of c squared. Okay, so here we use two properties in that first step. I use the product rule first and the power rule second. Okay, so now I have a difference of two logarithms. We'll rewrite that as a quotient of two logs. So that will be log of, sorry, I said that wrong. We're going to rewrite that as the logarithm of a quotient. Okay, so we have one logarithm of a plus b, a minus b, and that is over c squared. So a single logarithm of a more complicated expression. This one, it's pretty easy to multiply out that, what happened there? This binomial in the top. So let's go ahead and do that. So that will be base 2 log of a squared minus b squared over c squared. Okay. All right, so that does that one. Okay, once again, we're going to do this exact same thing. We're going to rewrite each of these as a single logarithm. Here we've got natural logs. The coefficients of 2 and 3 are going to need to come inside as exponents. So we'll have natural log x squared minus natural log y cubed. We'll rewrite that as natural log x squared over y cubed. Okay, here 1/2 log p plus 2 log k. I'm going to call that log p raised to the 1/2 power plus log k squared. Okay, that p to the 1/2 power, I'm going to go ahead and make that the square root of p. And then we've got a sum of two logarithms, so we'll rewrite that as a single log of the product. So that's the log of the square root of p times k squared. Note that the k squared is not underneath the square root sign. Okay, in the next few examples, we're doing the same thing, only backwards. And we're to rewrite each expression as a sum or difference of individual logarithms. The directions here could also be expand. So here we've got the base 2 logarithm of 7x over k. So it's a log of a quotient. We'll rewrite that as a difference of two logs. So we have log base 2 of 7x minus log base 2 of k. And then before we continue here, I wanted to point out a couple of things that you need to be really careful of, especially as you're doing homework and tests online. Be careful when you go to enter these logarithms on the computer that you put the base in. It's very common for people to just forget the base on here, because you don't even really need the base to answer the question. Like if this was log base 9, you wouldn't really do it any differently. It's just 9s instead of 2s. So it's very easy to forget that base. And when you type it in wrong, then you get the wrong answer and it's annoying. So make sure to pay attention to the bases. The second thing is, again, on this, you need to go all the way with it. Like here, am I done? And no, because that 7x can be broken up more, right? So you want to keep breaking things up until you can't break them up any further. So this 7x, that should be log 7 plus log x. Okay, x came out bad. Okay, so just like that, right? Okay, not quite. I left off the 2, right? And I just told you not to do that. So that was on purpose, in case you're worried. That's log base 2 of 7 plus log base 2 of x minus log base 2 of k. Okay, so that's the whole thing. We broke it up until we couldn't break it up any further, and we didn't forget any of the bases or put down the wrong one. Okay, so this one a natural log, so it'll be natural logs all the way through, but it is a complicated one. We're going to have a log of a quotient. I'm going to first split that into a difference of 2 logs. So we'll have natural log 3x squared y minus natural log w8. If you are comfortable with skipping steps and you get the right answer, then that's great. If not, that's okay. Go step by step. Because I'm here trying to show you, I'm going to show all the steps. So if you wish to skip ahead, I'll never know. So here we have a product of 3 terms first. So I'm going to write that as natural log 3 plus natural log x squared plus natural log y minus that natural log w8. Okay, so now we have 1, 2, 3, 4 terms. And so the 2 places where there are exponents, I'm going to use the power rule to bring those exponents around front. So we'll have natural log 3 plus 2 natural log x plus natural log y minus 8 natural log w. Okay. They're all natural logs, and nothing can be broken down any further. Okay, good. So now let's try this one together. So you should take a minute, pause the video, try this one on your own, and then we will go through it together, and you can see how you did. All right, so we have natural log of a quotient again. So we're going to take the natural log of a squared minus the natural log of b cubed c4. Okay, so in the next step, there's going to be a piece that we have to be really careful of. So the natural log a squared, I'll go ahead and bring that 2 around front. That's not the tricky part, 2 natural log a. So now the thing is, what's being subtracted here is this natural log of b cubed c4. That's a product. So we're going to split that into the sum of 2 logarithms, but right now all of that is being subtracted. So I'm going to take that thing and wrap it in parentheses, natural log b cubed plus natural log c4. Okay, it's a very common mistake to leave off those parentheses, but then that would imply that only the b cubed part is in the denominator, but the c4 would have been in the numerator. Okay, so be very careful about those parentheses. Okay, in the next step, I'm going to distribute the parentheses, and then in the step after that, I'll take care of that exponent. So we have 2 natural log a minus natural log b cubed minus natural log c4. And then let me bring those exponents around front. So we have 2 natural log a minus 3 natural log b minus 4 natural log c. Okay. All right, so that does that one. We have a couple more. All right, so this one is going to be the log of a product. So we'll write this as a sum of 2 logs. And then the second piece has a square root c in the denominator. So we're going to have a quotient, log of a quotient in there, and that'll end up being written as a difference. So let's see how this looks. So it's all common logs. So we have a squared and then log b squared over square root c. All right, so we've done a couple of these. I'm going to see if I can do 2 things at once here. The log of a squared, I'm going to bring the 2 around front, so we'll have 2 log a. And then here, this log of b squared over root c, that's a log of a quotient. So that's going to end up being a difference of 2 logs, okay? And also, the exponents are going to come around front. So that's 2 log a plus, and then log b squared, that will be 2 log b, and then minus, because that root c is in the denominator, 1/2 for the square root log c. Okay, if you need more detail on that, let me know. Okay, we got one more. Natural log, and then it's a quotient, so we'll have natural log, let's do it up here, natural log x minus natural log square root 2 plus x. Okay, natural log x, and then this square root, that's the same as a 1/2 power, right? Is the same as taking a square root. The natural log x still here. We'll bring that 1/2 around in front. So it's 1/2 natural log 2 plus x. And then you're going to stop. Okay, it's not natural log 2 plus natural log x. There's no rule about the log of a sum. So you're going to have to stop right there. Okay. All right, so what we've been looking at has been basically kind of mechanical changes to expressions, how to apply these properties to either expand or combine logarithms. The next part is involving something called the change of base formula. And what that is about is this. As you know, all right, so let's try that again. So as you know, in your calculator, you're able to find regular common logs and natural logs. There's a button for each of those. But what if you need the log of log base 4 or something? How are you going to do that? And that's what this is about. How do you find other logarithms? It's the change of base formula. And it goes like this. If you want the base a logarithm of x, then pick one of the logarithms that you know, like base 10 or base e, one of the ones that's built into the calculator, and you're going to make a fraction. The top is the logarithm of whatever you're trying to take the log of, like the x here. The bottom is the log of the base you're trying to change away from, okay? Here, this one on the right, I picked log log, okay, right? Because that's the one people like better. It could just as well have been the natural log, okay? So log base a of x is also the natural log of x divided by the natural log of a. Whatever you do, don't have like natural log x on top and log on the bottom, okay? That's wrong. One or the other, okay? Make it either log on log or natural log on natural log. And incidentally, it could be other logs if you want. So you could have log base 12 of x over log base 12 of a. But virtually nobody does that. The main use for this is to have something we can put in our calculator. And calculators have base 10 logs and base e logs. So you'll almost always see the change of base formula used just with base 10 and base e. Okay, so let's try it. So let's say that we want the base 2 log of 10, and we want to round this to the nearest 100. So let me use the common log one first. So this would be log 10 over log 2. Okay, so let me go to my calculator, calculate that. Log 10 divided by log 2. Well, log 10, you know what that is. That's 1, right? But let's see what log 2 is. Log 10 divided by log 2. Okay, 3.3219. 3.3219. Okay, so again, what did we just find out? Well, raise 2 to the power of 3.3219, and let's see what we get. 2 raised to the power of 3.3219. And you get 9.99998 because I round. Okay, so again, what we're finding here is the number that you'd raise 2 to get 10. I know 2 cubed is 8, 2 to the 4th power is 16. If you want 10, you're going to go 2 raised to the 3.32 power. Okay, so now, just to show that you can do it, let me do the natural log one. Natural log 10 divided by natural log 2. Okay, natural log 10 is 2.3025. And natural log 2 is 0.693. 2.3025 divided by 0.693 is about 3.225, which I rounded a lot more this time, but it's still like almost 3.3. Okay, I rounded a lot, I guess. Okay, but it worked for the natural logarithm too, okay? All right, so now we're going to find the base 3 logarithm of 7 to the nearest thousandth. So most of the time, people like the common log. Of course, either one will do. Just make sure, again, that you use the same one on the top and bottom, right? So this will be the same as the log of 7 over the log of 3. So that's log 7 divided by log 3. And that's about 1.7712. Okay, and then just check 3 raised to the power of 1.7712. That's 6.99966, thereabouts. Okay, so that's how you find logarithms to other bases using the change of base formula. All right, so what we have coming next is basically examples. Okay, we finished virtually all the instruction for this section. I just wanted to do some examples taken out of the homework. So let's do that. All right, so here, I think we did already a lot of these expanding logarithms thing. Let me do just 2 more. Log base b of 13/17. This will be log base b of 13 minus log base b of 17. Okay, here log base 2 of y to the x power. That's x log base 2 of y. Okay, expanding. Okay, in the next part, we're doing the same thing but backwards. So let me do number 12. Number 12 is natural log A minus natural log D. So that will be natural log A over D minus the natural log of C. And then this is again a difference of 2 logs, so we'll turn that into a log of a quotient. So that's natural log A over D over C. Okay, and that is natural log A over CB. Okay, one with a minus sign in front, that looks pretty neat. Log base B of 1/7. I'll call that log base B of 1/7 raised to the -1 power. And that -1 power is going to make it a reciprocal of the 1/7, right? So we'll have log base B of 7. All right, so there we've rewritten to a single logarithm. This is going the other direction. Okay, I think we did already a lot of those. Let's do, how about 18 looks good. Let's do number 18. So this is natural log, and it is a product, so we'll rewrite that as a sum. So natural log y plus natural log square root of y over 1 minus y. Okay, so the natural log y in front is good, it's done, so let's leave that. This natural log of a square root, that square root, remember, is the same as a 1/2 power. So we're going to bring that 1/2 power around front. So that's 1/2 natural log y over 1 minus y. Now, you'll notice that this 1/2 is a coefficient of this whole logarithm. So when I turn it into that log of a quotient into a difference of 2 logs, both of them are going to get multiplied by the half. So we'll have natural log y plus 1/2, let me stick some brackets there, natural log y minus natural log 1 minus y. Okay, and then let me go ahead and distribute that 1/2 now to get rid of those parentheses or brackets. So we'll have natural log y plus 1/2 natural log y minus 1/2 natural log 1 minus y. And then again, you're not going to do anything to the natural log 1 minus y because there's no rule about a log of a difference. So that is as good as it gets. Okay. So again, we were expanding. So this is once again going the other direction. We already did that a lot though, so let's skip it. So here, this is for the following exercises, rewrite each expression as an equivalent ratio of logs using the indicated base. So that's basically saying use the change of base formula to figure it out. In 25, we're told to use base e, so that means natural logs. So we'll have natural log 15 over natural log 7. Okay, and that is the correct answer, right? They've just asked us to rewrite this as an expression. If you want, though, you can actually go ahead and compute this. I'll do it in a minute. For this one, 26, we're to do base 10. So I'll have the common log of 55.875 divided by the common log of 14. And again, that would be the right answer for this one. I'm going to go ahead and do log 15 over log 7 because, frankly, I'm curious what it is. Natural log 15 divided by natural log 7. That's about 1.391. And then 7 raised to the 1.391 power. It's going to be like 14.9806. This would have been better if I had written down more digits, okay? But the two boxed answers are what we want to see here when we're just rewriting it in terms of that other base. Okay, a couple of more examples. So here in 30 through 32, it says for the following exercises, use properties of logarithms to evaluate without using a calculator. So let's try 31. Let's do 31 first. Okay, so this is 6 log base 8 of 2. Let me just rewrite it down here first. Plus, and then it's a fraction, log base 8 of 64 divided by 3 log base 8 of 4. Okay, so it says to use properties of logarithms to do this. So I'm going to bring in the 6 as an exponent for this first part. So this will be log base 8 of 2 to the 6th power. And I'll figure that out in a minute. For the next part, we'll have log base 8 of 64. We could do something with that. I'll do it in a minute. The 3 in the denominator, I'm going to bring that inside as an exponent. So we'll have log base 8 of 64 in the top and log base 8 of 4 cubed in the denominator. Okay. So 2 to the 6th power is 64. Okay, and then here we'll also have on the right side that fraction log base 8 of 64. And then down below, 4 cubed is also 64. So we have log base 8 of 64. So this fraction on the right is just equal to 1, right? So that's equal to 1. Log base 8 of 64, that would, that's the number that you'd raise 8 to get 64. And I know 8 squared is 64, so that part is equal to 2. 2 plus 1, 3 for the final answer. All right, so that does it for that one. For the following exercises, use the change of base formula to evaluate each expression as a quotient of natural logs. So here we want, let's do 35. Okay, we want log base 6 of 5.38. So we'll say natural log 5.38, and that's divided by natural log 6. Okay, let me see what I get. 0.9391. And then just to check, 6 raised to the 0.9391 power. 5.3797. Okay, and that sounds close enough to the 5.38. I think we did a good job. All right, that takes us to the end of 4.5 on log properties. What you want to do is, I think, is write those properties on a 3x5 card or a piece of paper or somewhere handy that you can have next to you as you do your assignment. There's basically only a couple of operations to do here. Take an expression that is a single logarithm and expand it into sums and differences of logarithms, or go the other way, start with the sum or difference of logarithms and apply those properties to kind of pile it all together. And then we also had some problems where we were basically evaluating some of these expressions. So anyways, that takes us to the end of section 4.5. In the next section, we'll be working on actually solving equations, and we'll have some use for these properties in that section as well. So in the meantime, let me know if you have any questions, and have a great day.